Okay, so in this section, we are going to talk about the product rule and the quotient rule, and they are going to be rules for taking the derivatives of products of two functions and quotients of two functions. So the product rule will tell us how to take the derivative of two functions that are multiplied together. And it's important to remember that this is not just going to be, so the derivative of f times g, or I'm going to write it, no, actually, I'll include the, the variable here, so f times g of x, and that is not equal to, so not equal to f prime of x times g of x, or sorry, g prime of x. Okay, so we can see an example of this by just looking at some very simple functions. So first of all, if we look at f equal to x squared and g equal to x cubed, then we know from the power rule that the derivative of x squared is 2x, and the derivative of x cubed is 3x squared, right? Now, if we multiply those two things together, f prime of x times g prime of x, we get, let's see, well, 2x times 3x squared, which would simplify to 6x cubed. Great. So that's on the one hand, and then we're going to compare this to taking f times g. So to do that, we just multiply their equations together. So x squared times x cubed, which is x to the fifth. And then we know that the derivative of x to the fifth is, maybe I'll create a little bit more room. So the derivative of x to the fifth, there we can use the power rule again, and that is going to give us 5x to the fourth. So notice that when we multiplied the two derivatives together after taking the derivative separately, we got something different than when we first multiplied the two functions together and then took the derivative of that. So that indicates that the derivative of a general pair of functions being multiplied together is not going to be as easy as just taking the derivative of one and multiplying it by the derivative of the other. Okay, so this is good to keep in mind. Okay, so I wanted to say that these are not the same. Oh. Right. Okay, so what is the product rule? So how do we take the derivative of two functions being multiplied together? So what we will get is the derivative of f times g is going to be equal to the derivative of f times just the regular g function. We don't do anything to that. And then we add the function f, just plain, multiplied by the derivative of g. So see that we have two terms, and in each of them we have exactly one derivative. So in the first one we have f prime, and then g is left alone. In the second one we have g prime, and f is left alone. Right? And so also, if we want to write this in Leibniz notation, we would just replace f prime with df over dx times g of x, and then f times, this would be dg dx for g prime of x. Okay, now let's do an example where we apply this. So we want to find the derivative of f times g of x. So notice that this is a little bit more compact a way of writing what I wrote up here, which was f of x times g of x. You should be careful and note that this is a small dot. It is not an open circle, which indicates that we're taking the composition of two functions. So this is not composition, this is multiplication. Okay, so we just want to apply the power rules. So the derivative of f times g of x, if you want to write this with prime notation, I would write it f times g prime of x. So that's where you would put the prime to denote that this is the derivative of this function. And then we apply the power rule. So what we get is, just to make everything clear, I'm actually going to, going to move this down. So normally we would do this all in one step, but since we're just learning this, I'm going to do it in a few steps. So it'll be convenient to just take the derivative of f first, and then also the derivative of g, just so we know what those are going to be. And so here we have a constant multiple, that's 5, so that stays out front, and then e to the x, the derivative of that is just e to the x. And also, if we want to compute g prime of x, this is just a polynomial. We'll get 20 times the power rule applied to x cubed, which would be 3x squared. And then this negative 30 is just a constant, so that part will give us 0. If you want to remind yourself that that's how derivatives work, you can just write plus 0. And then when we simplify, this will give us 60x squared, right? And so we just apply this formula. So this one up here, and so we'll take our f prime of x, so that's 5e to the x, and multiply it by the formula for g, so that is this 20x squared, x cubed minus 30, and then we add to that the formula for f, that's 5e to the x, times the derivative of g prime, which we computed. So that was 60x squared, right? Okay, so that is our answer, and I'm not going to simplify it. You could simplify it if you wanted to, but generally when we're doing these derivatives just for the sake of doing them, you don't need to simplify them, but in the future we may be solving equations involving the derivative, and in that case, of course, it helps to simplify. Okay, but in this case we don't need to worry about that. Now number 2 is given in a little bit different of a form. We still need to use the product rule, but we're not told what the functions are that are being multiplied together. So we have to look at this function and realize that there's sort of two pieces going on. So the first piece is, oh, that's not how you spell piece, is it? There we go. First piece is x, and the second piece is e to the x. So see that we have x being multiplied by e to the x, and we can see those as separate functions being multiplied together. So what we want to do is define, let's see, so I'm using f here, so maybe I will use g and h. That's unfortunate. Let me change this to an h. I don't know why I didn't do this earlier. Okay, so I'll change this to an h, and maybe I'll fix the PDF as well, so yours shouldn't say this. Okay, so h of x, we want to take the derivative, so we'll have one function being x and the other function being g. It actually doesn't matter which you choose to be f and g, that's just, you know, a label. You could swap them, it's fine. Okay, so we should also take the derivatives of these. So the derivative of x is 1, derivative of g is e to the x, and then the derivative of h, which is the x times e to the x, will be, well, we should use the product rule in this case. So we'll get first f prime times e to the x plus x times e to the x. So these two are matched up and these two are matched up. So that's how you can visualize it. I'll just rewrite this as x e to the x plus x e to the x. Okay, so one thing to note is that with the product rule, it doesn't matter which term you write first because addition is commutative. Commutative? I believe that's the term. Meaning that if we were to swap these two, we would get the same exact thing. It's just saying that if we add two numbers together, it's the same as adding them in the other order, right? Or if we add two expressions together, it's the same as adding them in a different order. Okay. So that was just to say it doesn't matter if you want to take as your first term f times g prime or f prime times g. Okay. Here we want to find the derivative of g of x. So I'm also going to change this one to be, let's just use capital G for this. So, right. So we want to compute g prime of x, and so see that this is sort of factored already, and so we might want to take this first piece to be f and the second piece to be g. So we'll just split it in the way that it's already split, right? And so see that e to the x is being multiplied by this function. That means that f is going to be e to the x, and g is going to be x plus 3 root x. And so f prime is e to the x, g prime is 1 plus, so to apply the power rule, we should first rewrite this as x to the 1/2, and then we can see that the power rule applies. So we'll get 1/2 x to the minus 1/2, and maybe we'll do a little simplification. So that would be 1 plus 3, maybe I'll simplify this all the way. So it would be 3 over 2. This negative 1/2 would mean that x will go into the denominator. That's the negative part. And then the 1/2 means that we take the square root. So 3 over 2 square root x. Okay, and then g prime. This is just a matter of using the formula that we have. So f times, or I guess we usually start with f prime, but again, it doesn't matter. So f prime, which is e to the x, times x plus 3 root x, and then plus the other pair, So that'll be e to the x times 1 plus 3 over 2 root x, like that. Okay, so that is your answer for that one. Now, this next problem is something that's sort of in context, so it's a word problem, and we can see how we might use the product rule in this case, right? Okay, so this says that the population in Richmond, Petersburg, Virginia was 9. Actually, I'm going to highlight all of the information that we're given. So that it was 961,400, and the population was increasing at a rate of 9,200 people per year. And this was in 1999, right? The average annual income per capita was 30,593 and was increasing at a rate of 1,400 per year. And then we want to use the product rule to estimate at which rate the total personal income was rising at that time, so in 1999. And we want to explain the meaning of each of these terms. So, what we can do, first of all, we're looking at 1999, and we want to notice that the rate of change, so we're given 2 rates of change, and they are talking about things per year. So that means that we should use our input variable. We'll probably use t because that's what we usually use for time. So input variable is time, which we will denote t. And since we're talking about 1999, we'll say this is time since the year, so the time in years. Since the year 1999. Okay. Now, we should also label the other things that we were given. One thing that I want to point out is that we're given 2 values, right, of certain things, and then we're also given 2 rates, and we're told to use the product rule. So it's likely that if we look up at the product rule, we're going to take one of the rates and multiply it by one of the values that we're given, and then we'll take we'll take the other value that we're given and multiply it by the other rate, right? Okay, so let's label. We're given the population, so we'll use P for population, and P is a function of T. And then we are also given the average annual income. So we'll use A for that. This will be the average annual income. Okay. And then we want to figure out what how fast the total personal income was rising. So maybe this is I'll do this in a different color. We want to find the rate at which the total personal income was rising, right? So we're looking for the derivative of total personal income, right? We want to compute, maybe I'll write down so we should label the total income. This will also be a function of t, as we'll use T, capital T, for total income. And let me put this here. So we want to compute the derivative of t in 1999. So remember we said t was measured in years since 1999, so that would be 0 years. And this is what we want to compute, t prime of 0. Okay, now let's write down the information that we're given in the problem in terms of the labels that we've now given for everything. So let's see. So P, the population was this amount in 1999, so that means P of 0 is going to be 961,400. And we are told that this population was increasing at a rate of 9,200 people per year. So that means that's the rate of change of the population at time 0. So we also get that P prime of 0 is equal to 9,200, right? Okay, and the average income, we're told that in 1999, so at time 0, this was equal to 30,593. And then we're also told how fast it was changing. So this was increasing at a rate of $1,400 per year. Okay, so that is the rate of change at that particular time. Therefore, it's the derivative of that function at that time. Okay, so see that we have these pieces that look like what we need to find the derivative using the power rule, right? And that's exactly what we have. So t prime, I guess it's important to note. So the total income, I'm insinuating that this total income is equal to the population times the average income, right? And so if you think about that, hopefully you can convince yourself that if you take the entire population of the city and multiply it by the average annual income, you will get the amount, just the total income of the place, right? So we get that the total income is equal to population at the time t times the average annual income at the time t. Okay, and since this is the case, we have two functions being multiplied together. We can use the product rule to find its derivative. And let's just write down, so we're not looking at all values of t, we're looking in particular at t equals 0, which is in the year 1999, right? So t prime of 0 is going to be we'll go with p prime of 0 times a of 0. And then the second one will be p of 0 times a prime of 0. Right, so then we just plug in our numbers and then multiply this out. So we would get 9,200 times a of 0 is 30,593. And then p of 0 is 961,400 times 1,400. Okay, so you can plug this into a calculator, and you should get that this would be, let's see, is that 627,415,600. So that is how fast the total income earned by everyone in Richmond, Petersburg, Virginia is how much that is increasing per year. So this is dollars per year would be the correct units for that. Okay, now it also asks us to explain the meaning of each term in the product rule. So what we have in this first piece is we have the rate of change of the population at 0 times the average annual income at 0. And so what this tells us is so remember P prime of 0 is telling you how fast the population is changing. So this value, when we multiply these two things together, is telling us how much, I'll try to fit this in here, how much the change in population is contributing population is contributing to the change in total income. Okay, in total income. There we go. So this is sort of like assuming that the average income is going to stay fixed, and then figuring out how much the change in population is going to create a change in the total income. But then also the fact that the average annual income is increasing is going to increase the total income, right? So that is taken into account by the second term. So this is, so this is how much the change in average income is, or contributes to the change in total income. Right? Okay. So I think that this example is really great for understanding why it is we get the formula that we get for the product rule. Even though we don't prove the product rule, hopefully it makes sense what each term is representing, at least in this particular context. So I would encourage you to think over this problem if you don't understand it right away, because I think it can help make the formula more concrete and have more meaning, right? Okay, so next we'll talk about the quotient rule, but we'll do that in the next video.